A warm welcome to Scott Chacon. Thank you for a talk. I'm astonished how many people are here. It's the first time I see a full room here in La Fontaine. Thank you. Have fun.
Thank you very much. Boy, the pressure's on. Now I really feel like I have to deliver here. So it's nice to have this great full house. Thank you all for coming out. It's great to be at FOSDEM. So this is not, I feel like this should be kind of a keynote type thing with this nice big audience, but it's really going to be a bit of a technical, boring talk. So really, bear with me. So just to introduce myself a little bit, if you don't know, my name is Scott Chacon. I was one of the co-founders of GitHub. I assume most of you know GitHub at this point. It's been a little while. I used to do a lot of talks and go around and try to convince people to use Git and why Git was cool. And now it's been a while since then, but it's a very different type of talk. So as I've been giving talks, what I've kind of learned is that there's some people that have never used anything. Actually, raise your hand if you've never used anything that's not Git. Wow. Oh, I feel so old. All right. I also I wrote this book called Pro Git. So if you go to the Git website and you read the book there, that's my book. It's an open source Creative Commons license. So a lot of times if you search for something on Google or something with Git, it'll hit this, which is always embarrassing if I forgot something and then read about it in my own book that I wrote, which happens more than zero. And now I'm working on a Git client called Git Butler. So if you're interested in that, I'll talk about it a little bit later on. We just opened it on GitHub, so I'll get into it a bit. But what I really want to go through is Git. So how many of you use Git on the command line? OK, so yeah, fucking nerds. It's not worth that. So how well do you know Git, right? Actually, throw out a number if you think you know how many commands, how many Git commands actually exist. Somebody said 400,000? So there's about 145 Git commands that you can type Git something, right? A lot of them are useless. A lot of them are not useless, but are useful for scripting or in the background or something like that. There are 82 porcelain commands. There's 44 main ones, normal stuff that you would do, add, commit, push, pull, rebase, stuff like that. There's 11 manipulators, so config and reflog and things that you don't use that often but kind of give you more metadata. Bunch of interrogators, some interactors. Most people don't use these, right? I mean, send email, you might if you're working with a mailing list with Git, but P4 or SVN or CVS, or there's a lot of CVS import. There's a lot of those types of things that are around. Almost legacy. There's a lot of sort of legacy stuff. And then there's 63 plumbing commands. So there's a lot of stuff like cat file and things like that you can use. You can use to script a lot of times. But for the purposes of this talk, that's not what I'm going to be talking about. I'm not particularly interested in the plumbing commands. I'm not going to go into the sort of nitty-gritty details of Git. I figure if you're scripting something, if you're using libgit 2 or something like that, you already know most of this stuff. That's not really the point of this talk. The point of this talk is that I've started talking about Git more often with the Git Butler stuff, and I've realized that stuff that I took for granted that I thought kind of everybody knew because it's been around so long, a lot of people don't know. So this is really kind of a refresher and to talk about some stuff that's new. So there's a bunch of stuff that's new. For those of you that are more old school, that have been using Git for a really long time, you may not pay attention to what's new in Git. So I want to talk a little bit about that as well. There's still an average of 9 commits a day. There's 10,000 commits in the last 3 years. Do you know anything that's been introduced in Git in the last 3 years? Right? Like probably not. Probably most of what you've done, you learned 10 years ago or 7 years ago, whenever you started learning Git, and you don't know a lot outside of that. So that's kind of the point. This is my friend Nick. He actually introduced me to Git when we worked at Reactrix together in 2005. So this is when Git was 5 months old, when he had his first patch in, and he told me about it. So Git is old enough to drink. Not in the United States, because we're stupid, but here, certainly. So what has changed? What is new? What is interesting? So here's our agenda. I'm going to talk about some helpful config stuff if you don't already know. Most of you probably do. I'm going to talk about some oldies but goodies, some stuff that's been around for a long time that you just may not know. I'll talk about some new stuff that's been introduced in the last few years that you may not have noticed crept in, because there's not really like a Git newsletter that most of you guys probably pay attention to. And then I'm going to talk about some big repo stuff, which is actually very interesting to me that most of you may not know about, but may not also have a need for anytime soon, but I find it very interesting. And then at the end, I'm going to talk about some new GitHub stuff, some stuff GitHub has introduced since I left that I've recently kind of discovered and I find very interesting, so I want to make sure you know about it too. The style of this talk I want to call a shotgun buffet. So I'm just going to throw a bunch of stuff at you. Take what you might find interesting. If there's something that might make your daily life, a little bit easier, a little bit better, please, you also don't need to take notes. I put these slides on our blog at GitButler, so if you go to gitbutler.com, go to the blog, this whole slide deck is on there if there's something you want to reference later. So just keep an open mind, let the shotgun buffet hit you in the face, and see if there's something interesting at the end. All right, so the first thing is how to configure stuff, right? So I'm going to give you a whole bunch of commands that have little options, little command flags and stuff that you may not know about. When you learn them, you probably don't want to type them out every time. So you probably want to do a setup an alias of some sort. If you don't know how to do it, or if you haven't done this type of thing before, it's fairly straightforward. You just say alias dot whatever you want to type. And then if you type git that thing, so if I type git stash with 2 A's, it'll do stash dash dash all. I don't have to type dash dash all every time. So what I like to do is kind of set up a lot of things of how I like Git to work, and I'll show you a bunch of different things you might want to alias, but that's how you do that if you didn't know. And dash dash global makes it so that all of your Git repositories have that and not just the one that you're in. I actually like dash dash all for stash as well. This is kind of a side note, but if you use stash and you stash something, it kind of leaves it in a weird state. Dash dash all will take away sort of all of your untracked files and kind of do what I thought git stash would do by default, but doesn't. So just a side note. The other thing you can do is you can tell Git, if you say git, in this case bb, you can say run some other script and pretend like it's a git command, right? So you can script something, and the way you have to do that is by putting a bang at the beginning, and then it says, OK, I'll give this sort of a shell prompt, and I'll run it as. You can even put actual bash script on the command line that way, and it'll run that. So this is something that I put in a gist a while ago to try to give me a better branch output that does ahead-behind information and orders them by last commit, and even uses the git description, which most of you probably don't know that you can put a description on a branch, but it actually lists it out. Otherwise, Git doesn't do anything with that information, which is kind of funny. OK, the next config thing that I'll show you, and then we'll get into the really fun stuff, is include if. So most of you might know. Actually, is there water around here somewhere? The rate I'm speaking, huh?
They're on the side.
OK, great. Git config. So there's an include if directive. So normally how Git works is you're working in your local stuff and you run something and it needs to say, OK, I'm doing a commit. What's my email address, right? Or should I use GPG signing or something like that? And normally what it does is it looks in your local.git/config, and then if it doesn't find a value, it backs up into your global config, sort of the .git config in your home directory. But what you can do is you can set up something in between, right? So it actually has a third place to look in between those things. So in this case, I'm saying anything that's under the OSS directory, use this git config. So I can sort of overwrite my email address for my open source stuff. And anything that's in the work directory, use this git config. And so I can say, here's my work information for any of my work stuff, which is kind of nice to be able to have a little bit more flexibility. So if we go in here and we look at this git config, I'm saying, let's GPG sign stuff and use my GitButler email address. And if I run user.email outside of that, it says, here's the email to use. If I run user.email inside of that subdirectory, then it changes the default, right? So if you want to have sort of, here's all the stuff that applies to everything underneath this, then go ahead and do that. So that's the include if stuff. OK, so just the config stuff. Now, let's go into oldies but goodies. I might poll the audience a couple of times because you're all nerds, and I really want to know who knows some of this stuff and who doesn't know some of this stuff, because again, I've been doing this for a while and I don't always know. So who uses git blame? OK. Who uses git blame -L? Does anybody know what that does? OK. So It just blames a portion of the file. So normally you run git blame and it blames the entire file and pages it. If you know the line range, then you can say just blame this line range. And A, it makes it faster, but B, it makes it more understandable, right? Because it's not showing so much. And the other cool thing is that you can do exactly the same thing with git log. So I don't know if anybody's ever used this, but this is super cool. If you know a function and you want to know sort of the history of that function, you can run git blame and get sort of the one-liners. Or you can say git log and give it the range and the path to the file. And it'll only show you the commits that git blame would have shown you, right? But in order. So you can kind of get a little bit more of a story of how that function kind of came together.
Thank you.
Huh? Thank you? You are welcome. Well, you're going to love the rest of this talk. The other cool thing you can do is you can say git log-l and then give it like a function name, and it will try to figure out what that block is heuristically and do the exact same thing. So if you, it depends on the language, and I actually don't exactly know what that heuristic is, but you can say, for example, file, right? It'll say, okay, this is class file, and so it automatically gives me the line range for that and just gives me the story of what that is. All right, so that is git blame. The other stuff that git blame does, and that if you use a GUI or if you use actually GitHub, and this is particularly embarrassing because I wrote this implementation at GitHub, so when I shit on GitHub for this, it is entirely on me. But GitHub and most of the GUIs don't ignore whitespace by default when it runs git blame. And there's more options you can give git blame. So you can also say -c, which says detect code movement. So if you delete a function and then move it somewhere else in the file, it will remember that, and it will kind of ignore that movement, right, when you blame that thing. So it won't credit you if you moved a function as owning that. If you do it 2 times, I don't know how many people know about command line options where you give it multiple times and it does different things, but it is arguably not the best UX I've ever seen. And if you give it 2 times, it says, or the commit that created that file. If you give it 3 times, it says, or any commit at all. So it's much more expensive, but it can really help you get, if you have time, I mean, it's not that often you're running git blame, you might as well do this every time, right? Because it takes more time, but it's much smarter about trying to ignore stuff that doesn't matter. So for example, if we go back to this one, it looks like mostly Kirill did everything. If I run git blame -wccc and then give it the same thing, it gives me very different output, right? And importantly so, because Kirill moved this at some point, but I told it, ignore that, like follow all the renames and all the movement, and it turns out that Kirill actually had very little to do with any of this code, right? And so blame by default, a lot of times, if you're refactoring stuff, will not end up with the person who wrote that line of code. But you can tell it to do that, and it's I would set up an alias for this. Okay, and you can also see what file it was, right? So this file was changed multiple times, and then we can see it moving around and who edited it when it was named what file. Okay, another one, git log-s. How am I doing on time? I'm doing okay. Okay, git log-s, pickaxe. So this is a way that you can say, filter all my git log output to anything that has this regular expression or this string in it. So if you removed a variable or added a variable, anything with that string in it, it will just show you that. This is a really nice way of seeing when something was changed that maybe git grep wouldn't find because it was removed from the code base and you want to know when it was removed from the code base. The other thing is ref log. So this is a log of your references. If you haven't used this, it will do it by default on head. And you can run git ref log, and it will show you, okay, that you pulled, and you did a reset before that, and you did a checkout from a branch to another one, and you did a rebase, and here's all the steps of the rebase. But if you ever want to run like git reset and you think it's going to mess stuff up, don't be too afraid because you can run git ref log and see kind of what every step of that was, and you can always get back to where you were. So whenever the head is pointing at something, it has a log of that. Another real small thing, and then we'll move on to new stuff, git word diff. So if you run git diff, it will give you by default a line-based diff, which sometimes, especially if you're using Tailwind, can be really difficult to figure out what was the one class that was kind of added in the middle of this line. If you run git diff -- word diff, it will do it as a word diff instead, and so it makes it much easier to see if you know it's a word, sort of a word-based diff, what the difference is. Okay. And then the last one, I'm just going to say the last one because I can't remember how many there are. is re, which is reuse recorded resolution. How many people have this turned on? Do you know what it is? Okay, so a good number of people don't know what it is. If you have a merge conflict, you can tell Git, remember this merge conflict and remember how I fixed it, and keep that in memory. It actually keeps it on disk as a hash, but if I see it again, it can automatically fix it for me, right? So if you're rebasing stuff and you're hitting sort of the same merge conflicts over and over again, you can turn this on and you'll only have to fix it one time, and every time after that that Git sees it, it will automatically fix it for you. And so the way you do that is by saying re enabled. I would just turn this on. There's almost no reason not to do this. It's not super expensive disk-wise. And when you get a merge conflict, it says, hey, I recorded the pre-image for this conflict. And when you fix it, it says, OK, I recorded the resolution. And when you get the same conflict again, it says, hey, I staged this using the previous resolution. So I saw the same thing, and I just fixed it automatically for you. So it's very nice if you're cherry-picking a lot or if you're rebasing a lot. OK. So that's oldies but goodies. That's been around in Git for, all of those things have been around in Git for a really long time. How many learned something new in that section, out of curiosity? Oh, fucking fantastic. OK, so now there's some new stuff. So now nobody's going to know this. So one, there is a new option to Git branch called -- column, which if you've ever run Git branch, you'll see it just kind of lists them out in alphabetical order, which is one of my least favorite things about Git branch, because that's not usually what I want to see. But there's some new options recently that they have. One is column. So you can do -- column, or you can set a global config, column.ui auto. And then if it sees this sort of list, instead of sort of paging it as one line, it will try to put it into columns graphically for you. And the other one is branch.sort. So you can sort your branches by default by, in this case, reverse committer date. So I want to see the ones that have had the last commit first, right? The most recent commit first. And if I run Git branch now, it actually puts them into columns for me, right? So it's a little bit easier for me to kind of see what this is. So I set this on. I really like this Git branch output much better. The other kind of funny thing is that there's a new Git command called git column that just takes input and puts it into columns. It literally doesn't do anything else. So if you want to put anything into columns, now Git helps you. All right, another show of hands. Who uses force with lease? OK, good. So force with lease is the worst named and most useful option that I think Git has. But I'll go through a real quick explanation of what it does. So this is relatively common. Let's say that I'm Scott, and I'm working with somebody named Tom. And I edit a file. Can you guys read that? It's OK, right? And I edit a file, and I commit the file, and I push it to the server. And then Tom pulls from the server, and he gets that file change, and he changes the file as well, and he commits it, and he pushes it to the server. Fantastic. We've now collaborated. Except Scott doesn't have that change yet. And Scott just went to lunch and had a beer and thought, you know what? I really messed this up. I should have done it a little bit differently. And so he goes in and modifies the file and amends the commit, right? Or rebases his changes or something like that, changes the history. And he force pushes. Fantastic. So now Tom's change is gone, right? I just force pushed over it because I didn't think anybody had even seen that in the meantime. If you rewind instead and you say force with lease, what it will do is it will check to see what it thought the reference was. And if it doesn't match, it won't push it, right? Because it seems like it's stale. So you have to fetch first just to make sure you're up to date, and then you can push. If you push and it's the same, it will do the force push, right? As long as your reference was the last one that's on the server. So it's kind of a safe force push. So I just use this. If you do rebasing or amending or something like that, use force with lease. It's much safer than force, and it does the same thing in the right circumstances. OK, another thing. I'll go through this real fast. Signing commits. Who signs commits? Oh, wow. You are nerds. Yeah, that nobody, like, no, who signs commit? Like, usually it's somebody corporate because the company kind of makes them do it or whatever. But who signs it with SSH instead of GPG? OK, not very many. So there's now a new thing. Some people, not me, because I'm pretty smart, but other people have sometimes a problem getting GPG to work and kind of, reliably. And so, but all of us have SSH, and in OpenSSH, as of a couple years ago, I think, they released a new feature where you can sign arbitrary data and get a signature out of it. And so That has been incorporated into Git, and so now you can use SSH to sign your Git commits in the way that you used to. You can also do with GPG, but it does exactly the same thing. So if you want to use SSH instead of GPG, you can say, it's actually kind of funny because it's not called signing. It's the GPG format is SSH. And you can say, here's where my public key is, or here's where my signing key is. And then if you run git commit -s, this is what a normal git commit looks like, although I left out the message here. If I put that into, if I edit a file and I commit and I sign it and I look at what that file looks like, now I have this GPG sig, right? But it's actually generated from SSH. But the cool thing is that GitHub, you can upload your public key to GitHub, or even use the same one that you push with, and then GitHub will mark it as verified, or GitLab, or if you have your own server, whatever. If you can do SSH commit verification, it will verify. And then if I mean, this is kind of the problem with or why we're doing SSH signing, right? Is because you can put some other email address and do a commit and push it, and then GitHub will say, hey, this one's verified because I have the public key, and I match it to the email address. This one's unverified. And so if you're using GitHub or GitLab, these things will work. But yeah, if you're signing your keys, or you're signing your commits with GPG, you can sign them with SSH, and a lot of things will work that way as well. Little known, and nobody in this room probably will use this, but you can also put one guy in the front uses this, but you can sign your pushes as well. So you can sign the sort of ref updates that you push to a server. GitHub and GitLab do not support this, so most people don't use it. But I think kernel.org supports it, and there's a handful, or if you do your own, you can do this, and then you can create sort of like an audit log or a trust log or something like that that has sort of the ref updates and the signature. So that is doable, but you kind of have to run your own thing if you want to use that type of thing. The next thing is Git maintenance. Who's run Git maintenance? Oh man, oh! All right, so all you have to do, everyone do this today. Go into whatever repository you work on the most and run git maintenance start. Because what git maintenance start does is it adds, I mean, really what it does is it does this. It just adds this to your git config file. And it says strategy incremental, and I'll show you what that means in a second. But what it really does is it adds a cron job for Git to run in the background every hour or every day and do maintenance tasks on that repository, right? And most of the time, that's just going to make lots of things faster in a way that you'll never notice. So run it, because it's just going to make everything faster, and you won't have to worry about anything. So if you've ever run like a Git command and you see like, it's garbage collect, it's running Git GC, it's like garbage collecting or pruning loose objects or doing something like that. It's doing that, but in the background, so it doesn't have to tack it on to another command that you run, because there's something running in the background. So this is what strategy incremental does. It does mostly these four things. It does commit graph generation, which I'll talk about in a second, prefetch every hour, which I'll talk about in a second, loose object collection and incremental repacks of your packs. But really all that means is shit just gets faster, right? So if you want to run it and just have it go in the background instead of sequentially after you run a git command, you can do that. Git maintenance start, that's all you have to do. OK, so now, stuff that I'm curious, how many people in this room work on a repository that you would qualify as enormous? By enormous, would you say more than 500,000 files in your working directory? OK, good. Then there's 7 people in this audience that are going to find the next 20 minutes useful. So whether you like Microsoft or not, I have a little bit of a bias, because they bought GitHub, and that was nice for me. But whether you like them or not, they have put a ton of effort into large repository and mono-repository supporting Git, because they moved Windows to it. And Windows is enormous. So Windows is 3.5 million files on disk, 300 gigabytes to clone. Like, think about starting the job and trying to clone off of a Git repository, like GitHub or something, 300 gigabytes. For reference, the Linux kernel is 4.5, right? So it's a chore. And so what they did is that they put a lot of resources into making large repositories and mono repositories work relatively well in the Git ecosystem in the last 5 years. And I want to show you the tools that they did. So the first thing they did was they tried to do a virtual file system. And so you wouldn't have sort of actually all of the contents of the files. It would just be sort of on demand, and it would go to a special server that they had, and it'd request sort of file contents as it needed it in order to do something. But it looked like you had all the files until you actually tried to access them, and then it pulled them on demand. And then they thought, it's actually not necessary, and they created this project called Scalar, and Scalar tried to do a lot of the things that I'm going to, actually they did all of the things I'm going to tell you about now, but then over time all of that stuff actually just got shifted into Git core, and so now Scalar is just a wrapper around that in the Git for Windows binary. But everything's baked into Git, and you can use it on any system. So now it's just all in Git. So what is that? So there's a couple of things. One is prefetching, which I talked about with Git maintenance. If you run Git maintenance start, every hour your system will fetch from the server whatever project that you're on. It will not update your references, so it won't actually do what it does when you do a git fetch in that origin main updates, but it will get all the data, and it will keep the references to that data so that when you go and you run git fetch, that it's not getting almost any data. It always seems to me, even if you haven't fetched in 3 days, if you go and you run git fetch, it's going to be like, yep, I already have all the data. It's essentially a no-op. Here's your new reference, right? And so it just makes git fetch seem fast because it's doing it every hour in the background all the time. You can look at this. If you run git maintenance start, and after an hour you go and you look at your references, you look at the sort of for each ref just lists out all the ref. You can also just list .git/refs or whatever. There's a new thing called prefetch. All of the git commands ignore this very specifically. So if you run git log -- all, it will just 100% pretend that these don't exist, which it won't do for any other refs. But it pulls all of them down so that it doesn't GC anything that it pulled down, and it just does it in the background. It just makes fetches and pulls very, very fast. The next thing that they do is something called commit graph, which also Git maintenance will run for you and will build for you. But let's look at an example of a large repository. So this is the Linux kernel. If I pull down the Linux kernel, it has 1.2 million commits. If I run git log -- graph, -- graph is a little bit difficult because it has to walk all of the objects in order to figure out how to render even the first one, right? So it has to walk the entire tree because it doesn't know what it's going to find to be able to show you sort of even the beginning of the tree. So it tends to take a really long time. It can't incrementally do it. But you can run git commit graph, right? And it takes a while, but it is incremental, so it's only the first time, and then it can kind of add to that. And then you run it again, and it takes almost no time, right? Because what it's doing is it's sort of caching an index of all of the commit objects so that it can do commit operation or commit graph operations very, very fast. Now, you don't really want to go in and run git commit graph right all the time, but there's two different things you can do. One is run the maintenance thing that I talked about, which will do it automatically. The other is this. You can set this fetch write commit graph, and it will write it on fetch. So every time you kind of get new data, it'll write the difference update. And then all of your log operations are faster if you have a big repository. The next thing is file system monitor. So you don't have to do untracked cache. That's just caching untracked files. But FS monitor, if you've ever run git status in a very, very large repository like Chromium or something like that, if you have 400, 500,000 files, it takes a really long time, right? Because the way that Git figures out what has changed is it stats every file in your working directory, and that can be relatively expensive. So FS Monitor instead launches a daemon that looks at the file system and watches for inode events and updates a cache in memory that says this file was changed because I saw it get changed with my file system watcher. And so if you set that config value, then the next time that you run git status, Git will notice that the thing is running or not running, and if it's not running, it'll launch it, and the next time you run git status after that, it'll be very fast. So this is a status on the Chromium project on a bare checkout, which is, again, 470,000 files, and it takes 10 seconds, right? So if every time you ran git status, it took 11 seconds, it'd be a little bit annoying. If you turn this on and you run git status again, it's still relatively slow, but the third time you do it, it's very fast because now it's just running it out of the file system launcher. So again, if you have a really large repository, you can turn on the file system launcher. These are some sort of fake statistics that GitHub did where they did synthetic loads of 1 million files and 2 million files, and it just gets worse and worse and worse to do add and status commands, but with the file system monitor, it's very fast. Okay, thank you. And last is partial cloning. So if I clone, let's say the Linux repository, it takes a while because it's 4.5 gigabytes. If I say filter, I can filter out blobs. So it downloads everything except blobs. And so all of those are left on the server, but it downloads all the commits and trees. And it has to do 2 different fetches for this. One is the 1.5 gigabytes of commits and trees, and then the other one is the 243 megs of the working directory blob so that it can put something in my working. So it just takes the data I need for the very last commit. But I can still run graph operations and all of that. Or I can say no trees. And I don't know why it's blob none, but tree 0. But you've used Git for a while, so you understand. And that just doesn't bring any trees down either. It's relatively rare to use this, except for in CI build type stuff. But if you want to take a really large repository and make it so that it's a relatively fast download, like if you're working on the Windows repository or something like that, what most people will do, what Microsoft does, is they filter out the blobs. They do this blobless one. And then Git will automatically get new data as it needs new data, right? So it's almost like a virtual file system. And again, this goes down to 2 seconds instead of 4 minutes, 4.5 minutes, right? The bad part is that if you blame, it doesn't have all of the data for every blob file, and so it needs to fetch it on demand as you run a blame. So instead of a blame looking like this, it goes like this, right? So it just keeps pulling next versions down in order to run the blame. So if I look at sort of the difference, a blame from Linux on the full checkout is 4 seconds on a file, and on the blobless one is 45 seconds. So it does slow some stuff down. And there's a lot of other stuff. If you're really interested in large repository stuff, there's multi-pack indexes, there's reachability bitmaps, there's geometric repacking. GitHub has talked about a lot of this, have blogged very well about a lot of this if you're interested in it. But it tends to be, you have to have huge repositories. And then the last thing that I'll talk about in the big repo is monorepo stuff, which is sparse checkout. So how many use a monorepo at work? Or, okay, not bad, not bad. Thank you for the data. This is helpful. So sparse checkout is you can clone with no checkout and then say, here's the directories I want. And only those ones also you can say, I want a sparse index, so only they go in the index. And if you have a ton of subdirectories and you only really need to work with 3 of them, you can say, give me just my commits and my commits of my trees and none of the blobs, and just check out this one directory, these 5 directories or something like that, and then just grab the data as you need them, right? And it makes really, really large repositories much, much easier. So another example, we have git status. It takes 5 seconds. And I run this git sparse checkout and set build and base. Those are the 2 subdirectories I want in my Chromium build. And then I run git status, and it's much, much, much faster because it's looking at much less data. But those are the only 2 that are in my working directory as well. And when I do commits, it looks like the rest of the data is there, right? Like it doesn't pull them out, but I can just work with subsets. And it even tells you I'm only working with 2% of my track files. OK, last thing on our agenda. Actually, I do have one secret thing real fast. But GitHub stuff. So there's a bunch of GitHub stuff that you may not know about. There's allowed merge types. So if you go into your GitHub settings, you can say, I only want merge commits, or I only want rebasing. And then you get in a conversation with your coworkers, and you fight, and like people have actual physical arguments, and you figure out, are you a rebase shop or are you a merge shop? We're having beers later, so if anybody wants to have that argument with me, I'm more than happy to do that. Merge. But you can also do squash merging, which is arguably a good sort of middle ground for this as well, and set all these things. And then when you go and on GitHub, you can now sort of make sure that your repository sticks to that, right? So you can say enforce these standards. When you hit the sort of merge button, it will only give you the options that you have allowed it to give you. But if you try to push, say, a merge, you can tell it, I don't accept pushes with merge commits, or however you actually want to do it. You can make GitHub enforce a lot of this stuff now, which is kind of cool. I actually didn't know that until recently. You can also auto merge. So if you guys ever, if you turn on this requirements for some sort of status and you have some CI, okay, and you have some CI and you say allow auto merge, there's a button that says I will merge it as soon as it passes CI. But it's kind of nicer than going back and checking status and merging it later. So I use this all the time. There's also merge queue, which if you have a lot of commits, will kind of stack them all together and merge them at once. There's require a linear history. If you really like rebasing, you can force GitHub to not accept pushes that have merge commits in them. You can require signed commits, which goes back to the SSH thing, and so on. And then the last thing on GitHub is the PRs that have heads. So if you run git ls remote on GitHub repository, all of your pull requests actually have refs that you can pull down and that you can merge from. Most people don't know that. Most people think you have to add, like if somebody sends you a pull request in an open source project, that you have to add that as a remote and fetch from that and merge that in. But GitHub actually advertises all of these refs that you can pull from or fetch from directly, which is kind of cool. So you can put in something like, give me all my pull requests as actual refs, and then every time you fetch, it'll pull all of those down as local references, which is cool. Okay. And then, very last thing, I wanted to talk really fast about Git Butler, which is something that I'm working on with my team over here, which is we have this new thing called virtual branches. So we can work on multiple branches simultaneously instead of having to sort of stash stuff and switch branches. And so you can have sort of each lane is a branch. So this is one branch and another branch, maybe a bug fix. Like you're working on a feature and you see a bug fix, you don't have to commit it into the feature branch, right? You can and you don't have to switch. You can drag it over to another lane and commit it separately. And each one can kind of go into its own PR as though that was the only thing on disk, but it's a very kind of nice way of working. And it's open. So if you go to GitHub, you can take a look and see if that's something that is interesting for you. And that is the end of my talk. Thank you very much. And let's drink. Okay, so I wanted to have some time for Q&A if there's any questions or something that I can do. But we are buying beers right over there. It's a 9-minute walk at 6 o'clock at Loaf. So I would love to debate all of this or learn what your workflows are or anything. I'm very excited to meet everybody. There's a question over here.
Since you mentioned you were this, I cannot identity. So what about the range if does it not if butter doesn't and why does it have not do?
Sorry, say that. What? Why does GitHub not do what?
Git range if, like the comparing your if.
Why does GitHub not do git range diff? So I almost put a thing on range diff in here, but it's a very kind of specific workflow where you don't use it unless you're doing a lot of sort of rebasing series and you want to compare sort of a rebase series to another series to see if something changed. So yeah, if you do that, check out range diff. I have no idea why GitHub doesn't do that, except I think that GitHub, like a lot of services, like they try to say, here's what we think a workflow should be, or what a good workflow would be, and they build tooling around that and try not to do everything that could possibly, like every workflow that they see, in order to try to make it less confusing for people. So I think it's more that people in GitHub don't use that type of workflow. Like at least when I was there, I can't speak for the last 8 years or whatever, but like we did not do a lot of rebasing. We did a lot of merging. And so if you're doing merges all over the place, then you don't need range diff. Like range diff doesn't really make sense in that workflow because you're not comparing, what is this patch series compared to this patch series and did I miss something? That's my guess. Is there another question? Oh. Yeah, it's a great question. Why do submodules suck everywhere is essentially the question. And it's funny because they always have. Like I've been working on this, as I said, I've been involved heavily in the Git project for more than 15 years probably. And there's not a single, even meetup of Git developers where they're like, we shouldn't have put submodules in there. Like And there's a lot of different reasons. I think what a lot of people are moving towards is monorepo, which is monorepo stuff where you just have everything in one repository, so you don't have to worry about a lot of the things you did submodule stuff for, but it doesn't cover every case. And even actually a lot of the stuff that I talked about, like the sparse checkouts and the sparse index stuff, I think don't work well if you have submodules, because just nobody uses them that works on Git, and so they don't optimize anything. But yeah, I honestly don't know. From the companies that I've talked to in the last couple years, most people that care about that either use package management type stuff for that type of problem set, or they have a monorepo and they can start using some of these tooling. Although GitHub's not good at monorepo support, so that becomes the problem now, right? Like locally it's fine, but now all your issues are in one repository and all of your, yeah. But yeah, it's a good question. In the back. Oh, wait, no, sorry. I'm not in charge.
So with this SSH signing,
Yeah.
is it possible to specify more than one key?
Yes.
Okay.
Yeah, you can. I mean, wait, when you're signing it or verification? Like the key ring? When you're signing, I mean, you have to choose a one to sign the commit with, if that's what you're asking. But you can, is that what you're asking? I don't know what you're asking.
Okay, so my use case is I have like 3 keys set on, let's say, GitHub.
Yeah.
Because I'm using, YubiKeys and the SSH keys are connected to the YubiKeys and I want to have backup and backup of the backup, obviously. And if I don't have my first key inserted, I would like it automatically switch to the second SSH key and the physical second.
I have no idea. Yeah.
Okay, so my question would be, why can't force with least be the default force?
Yeah, I mean, the thing of why can't force with least be the default, it probably would be a good idea, or to have the more aggressive version be the longer option. I think it's more just that Git is always backward compatible, right? Like that's it, always. Like for 19 years now, there's like almost nothing that I could do. I could have scripts that I wrote in 2005. They would probably still work with the current version of Git. And it's a great thing about Git, right? Like it's actually very, very nice that they really don't deprecate very much. And they make sure everything's always backward compatible. It gets into trouble. There's actually stuff I didn't really talk about. Like there's like git switch instead of checkout that's closer to just being able to switch branches and not do other stuff like revert file contents and things like that. So they kind of add more to the user interface in order to try to make it less confusing, but then there's just now more commands that do overlapping things. So, but yeah, it's because they don't want to be backward compatible on anything, and they just assume you're going to set up aliases for new stuff that's cool.
And I think in that case it would be great if it would be configurable.
So, sorry, it might be. I'd have to check. If you go to like the git config man page, there's 10,000 things that you can configure. It might be possible. I don't know if you can overwrite what force does to force with least by default if you actually put it on the command line. But you could probably change what the default behavior of git push with no option is, right? But that's not usually what you want to do. So it may be different. There may not be one. I'd have to look. Or you'd have to look. Actually, you look. Yeah.
Thanks for the talk. And first of all, it's squash, no other options are allowed. My real question is, if you are like back at the Git development team, what would be the direction that you would like to see Git moving more? Like we have a lot of features for monorepos. What are the things that you think Git is missing?
Ah, what a great question. I mean, to some degree, I have a little bit of a cheat in that I'm writing a Git client. And so everything that I'm putting in the Git client is stuff that I kind of wish Git did. So I would like to be able to work on more than one branch at a time and being able to essentially have more than one index and more than one head that I'm working on simultaneously. I mean, we're building that, and I find it very valuable. So that is one thing. The other would be recording everything you do. It's a little bit frustrating that I can lose work in Git, but I can't lose work in Google Docs or something that just records shit all the like just save a CRDT of every file all the time. Like how expensive is that, right? Like it'd be kind of nice to say, show me what my working directory or this file or something looked like on Tuesday at 10 p.m., right? Like you can't do that. Git won't save anything you don't commit, really, right? Or stash, which is basically commit. But why not? Like there's no reason for a modern version control system. It's not network based. It's not disk bound, right? Like just save everything. It'd be nice to just say, watch this directory and make sure I never lose anything in it and help me craft commits when I'm ready to share. So those would be two big things that we'll probably, we've built both of those to some degree, but like even in core Git, I think it would be nice to have, Git hasn't changed. It was written for people that are submitting patch series to mailing lists, right? And it's very, very good at that. And I think GitHub kind of bastardized it a little bit to really go towards the pull request rather than talking about patch series and having communications over patch series, which has a different set of strengths and weaknesses. But like I said, it's backwards compatible. It hasn't changed really the user interface fundamentally, which is why a lot of you guys didn't know a lot of the stuff that I talked about, right? Like you just use the same thing all the time. I just use the same thing all the time. So yeah, it's a little bit difficult to go in a massively different direction for those reasons, I think. But there's lots of cool stuff we could do with version control, I think. Okay, one more maybe? How much time do I have? Yeah, one more.
So, you know the command line, but one question, do you ever use any visual tools?
Do I use visual tools? So I use GitButler. I've been using it for 3 or 4 months now, which I enjoy a lot. And I use Visual Studio Code with Vim key bindings because I'm kind of a nerd, but then also not. But I'm partially nerd, partially executive, so I have to do Visual Studio Code with key bindings. But before that, I think is a more interesting question, which was, what did I use? What do you guys use GUIs versus the command line? I used GUIs always for interactive adding because I just find it much, much faster to do interactive adding through almost any GUI than it is through the actual interactive add script that Git provides. I would love to do rebasing more drag and droppy or something like that, but I can also edit the stupid script and put pick and stuff all over the place. But for the most part, it's interactive adding. That's the thing I spend a lot of time in, and when I do, it's worth the context switch to go over to a GUI and say, I can make this much faster and much more specific than trying to go through, like hit 5 to choose the next file grouping and add them and stuff like that. So it's whatever's fastest. I think everybody uses the command line with Git still, not because it's the best thing that could possibly be, but because it is fast, right? And almost anything you do, it's faster than hitting a button that then calls that script, right? And so I always use the command line for stuff, unless it's something like interactive add, where really having a GUI adds something to the experience in a way that makes what I'm trying to do faster. Okay, that's it. Hopefully I'll see you for drinks later. Thank you very, very much. It's been a pleasure. Bye.